Let us see this chemistry question. Elements P, Q, R, S have 6, 11, 15, 17 electrons respectively. Therefore, P will form an electrovalent bond with R, Q will form a covalent bond with S, R will form an electrovalent bond with S, Q will form an electrovalent bond with S, Q will form a covalent bond with R. Very good. So the best way to do this question is to consider the number of electrons given. And you know that elements in their neutral state, in their free state, so the number of electrons is always equal to the number of protons. So in that regard, so that means the number of electrons can be taken as the atomic number. So that is because number of proton is equal to the atomic number. So therefore, the number of electrons given can just be taken as the atomic number. So we can write the electronic configuration of each. So for P now, the electronic configuration of P be 2, 4. So this belongs to group 4 element. This is a group 4 element. In short, this is even a carbon because the atomic number of carbon is 6. That's 2, 4. So let's talk about Q. Q is 11. That's 2, 8, 1. So this belongs to group 1. This is a group 1 element due to the last digit in the shell electronic configuration is always the one indicating the group that the element belongs to. So this one that we have here means that this element Q belongs to group 1. And if you look at this 11, that's even the atomic number of sodium. So this is sodium. So this is carbon. Let's go for the third one, R. Let's write the atomic number of R, which is 15. That will be 2, 8, 5. So which element is number 15? That is phosphorus. So that's phosphorus, P. So next, the next is 17, which is S. That's 2, 8, 7. That's 17. So this belongs to group 7, the halogen compound. So the halogen element. So the halogen family. So this element with atomic number 17 is chlorine, no doubt. So now, if you consider electrovalency is the type of bonding in which there is transfer of electron from one element to the other. The element that transfers electron is a metal, while the element that receives is the non-metal. It's a non-metal. So the transferer of electron are known as the donor, while the receivers of electron are known as the acceptors. So it always happens between a metal and a non-metal. So let's consider option A whether it's correct. So P will form an electrovalent bond with R. Where is R? R is 5. So P is carbon. Carbon does not form electrovalent bond. So that's wrong. So carbon always form covalent bond with whatever element it wants to combine with. So let's go for B. Q will form a covalent bond with S. Let's consider the Q. Q is sodium. Sodium is a metal. Metals do not form covalent bond. So they can rather transfer the electron that they have in their outermost shell. So sodium is not a covalent element. It doesn't form covalent bond. So B is also wrong. Let's go for the third one. R will form an electrovalent bond with S. Let's go for R. R is phosphorus. It will form electrovalent. No. Phosphorus cannot form electrovalent compound. With S, S is chlorine. So how many electrons does this want to transfer? So it's not easy to transfer 5 electrons. So elements usually transfer maybe 1 or 2 or maximum of 3 electrons. That's what it can give. And usually elements in group 1, 2, 3 are the ones that form electrovalent bond. So option C is also wrong. Let's go for D. Q will form an electrovalent bond with S. Let's consider Q. Q is sodium. Yes. So S is chlorine. Yes. So Q is a metal, while chlorine is a non-metal. Sodium is a metal, while chlorine is a non-metal. So sodium can transfer one electron, which is at in its outermost shell, to the chlorine to complete the octet state for this. So that means this is possible. It is only D that is possible. So therefore, the correct answer is option D. Thank you.